So in this lesson, our focus is to look at the various bonds present in organic compounds. So our first question to answer is, what holds organic compounds together? But before we proceed, if you haven't subscribed to our channel yet, please subscribe to the channel. Share the video with other colleagues that you know will benefit from lessons like this. This is the third lesson in this series of organic chemistry. So what bonds or what forces hold organic compounds together? This brings us to some two types of force. What forces are those?
Intramolecular forces and intermolecular forces.
Good. We will explain each of these forces into details, but before then, just look at this diagram. Just pause, analyze the diagram for a second before you proceed. So, intermolecular and intramolecular. And for purpose of this lesson, we'll be using ethanol to explain this type of forces present in organic compounds. Are you ready?
Yeah.
I think we are, right?
Yeah.
Okay. So now let's pick ethanol. This is a single ethanol molecule. And inside this ethanol molecule, we have various atoms that are coming together to form ethanol. What are some of the atoms you see in there?
We have carbon,
hydrogen,
and oxygen.
Oxygen, good. So we have two carbons out there. So what forces or what kind of force hold these atoms together? So inside each ethanol molecule, there are forces holding each pair of atoms together. So the first pair we'll be looking at is what?
Is the carbon-carbon bond.
So the carbon-carbon bond this way. So that black line between the carbon-carbon bond is representing the force or the bond between the carbon-carbon atom. So we have a carbon-carbon bond out there. The next one, we have a carbon-hydrogen bond. How many carbon-hydrogen bonds we have? We have the first one here, and this black line represents the force holding the carbon-hydrogen atoms. That's one carbohydrogen bond. They have the next carbohydrogen bond, and the black line also represents the force. And I think we have the third. Then we have a fourth carbohydrogen bond, and the fifth carbohydrogen bond. So in total, I have 5 carbohydrogen bonds in ethanol. And between each of them, there is that line representing the force or the bond holding them. Then you have what? The next one?
We have the carbon-oxygen bond.
Good. Carbon-oxygen bond, this one. The black line. So pay close attention to the kind of forces between the pairs of atoms. Then we have oxygen-hydrogen, this. Now, all of these forces, how are they called?
They are called intramolecular forces.
And most of the time, what kind of force are they?
They are strong covalent bonds.
Good. So all the forces we've just represented to you, highlighted in black lines between the various atoms, are known as intramolecular. Basically, intramolecular is found inside the molecule, holding the atoms together. Keep that in mind. And do these forces break during boiling and melting?
No, they don't.
Good. They don't. They are very strong, mostly covalent. And when you boil an organic compound or any other compound at all, these intramolecular forces do not break. So that is what we have about what? Intramolecular forces. Now we can compare these intramolecular forces to the force between members of a nuclear family. So you have the father, the mother, and their children. This kind of force between them or bond between them is really, really, really strong. And it is not easy to break. So this kind of force between the mother, the father, and their children can be compared to what? Intramolecular forces. This is the force that hold the individual members of the family together to form that nuclear family. I think that's clear, right?
Yeah.
That makes sense?
Yeah, it does.
Okay, so that's intramolecular. But look at this. In the world in which we live, you don't have just a nuclear family. Especially in some parts of Africa. We really focus on extended family as well. Some people do that a lot. So in extended family, we have nuclear families coming together to form extended families. Is that not so?
True.
Good. We have nuclear families coming together to form extended families. So keep that in mind whilst we link it to the explanation we have on the screen. So look at the bottle out there. In a single bottle of ethanol, we have several molecules of individual ethanols coming together, right? So we have 3 ethanol molecules represented on the screen. And for each of them, there is a hydroxyl group, which is polar. Hydroxyl group are referring to the OH group. And when we talk about the hydroxyl group being polar, don't stress yourself too much. What it simply means is that there is a part that is partially positive and another part that's not partially negative. And polarity of compounds will be explained in future videos. So what should they do so that they don't miss those kind of videos?
You have to subscribe.
Just subscribe, because there's a lesson out there for us on polarity, which will soon be released after this lesson. Good. So ethanol has a polar OH group, meaning one side is partially positive and another side is partially negative. So this is what happens. You know that positives always attract negative, right? So there's slightly positive hydrogen part of one of the OH would then attract the partially negative oxygen. And then the next molecule also does that. Partially positive attracts partially negative. So the molecules keeps going. So we end up having thousands of molecules linked by this connection between the positive and negatives of each of the ethanol molecule. Good. So remember we're talking about nuclear family and extended family members. So each of the ethanol is a nuclear family. But we have another nuclear family that is connected by family ties to another nuclear family. There's some kind of family union or bond between these nuclear families. So that also exists, right? But in terms of organic compounds, how are they called? These are known as intermolecular forces. So the first one we spoke about are known as what?
Intramolecular force.
Good. And this is known as what?
Intermolecular force.
The intramolecular force, where are they found?
So they are found between, forces formed between the atoms.
Good. So they are found between the atoms that make up a single molecule. What about intermolecular? They are found between
the molecules.
Good. So molecule 1, molecule 2, the force within them is intermolecular. But if you pick one molecule, the atoms, it is intramolecular. And between intermolecular and intra, which one do you think will be stronger?
Is the intramolecular bond, because it cannot be broken.
Good. So intramolecular bonds are not broken during melting or boiling. But the intermolecular forces are the ones that are broken during melting or boiling. And I think we see that also when it comes to the family system. The forces or the bond between mother and father and their children in a nuclear family is much more stronger than the bond you see between one nuclear family and another nuclear family. Although there's some kind of bond between them, those bonds are easily broken when there's some slight conflict. So you realize that maybe we have myself and my wife with maybe children. For one nuclear family, the force between us will be much more stronger. Then maybe I have a sibling who also has his family. Another sibling who has his family. We still have some kind of bond between us. But it is simple to understand that the force between myself and my wife and my children should be or will be stronger than the one I have with other nuclear families that I'm connected with. So I think that makes sense, right?
Yeah.
Good. So this is the type of force that is broken during hot melting or boiling. So here's the point. The melting and boiling point of this kind of molecules depends solely on the intermolecular force, not on the intra, because intra is not broken. So a stronger intermolecular force will mean that the boiling point will be higher. So in there are some families, their intermolecular forces, so to speak, is stronger than some families, some extended families. Some extended families, their intermolecular forces are not strong. So a little conflict, they break apart. Good. Now we have three common intermolecular forces that can exist in organic compounds. What are they?
So we have the dipole-dipole interactions, London dispersion forces, and hydrogen bonds.
Good. Hydrogen bonds, dipole-dipole, London dispersion forces. Good. So in summary, intramolecular forces, what are they?
So they are the forces that hold atoms together to form molecules.
Good.
While the intermolecular forces, they hold individual molecules together.
Good. So on the diagram we have on the screen, the black lines that are having yellow highlights between them, they are known as what?
They are known as the intramolecular forces.
And then the red dotted lines are
The intermolecular
molecular forces. And I think this lesson is quite easy to understand, right?
Very easy.
Very, very easy. And remember one thing. The common intramolecular force we have in organic compound is covalent bond. So that will be the focus of our next lesson. So what should we expect in our next lesson? That will be covalent bond in what?
In organic compound.
In organic compound. And when we are done with covalent bond in organic compound, we'll go back to pick the intermolecular forces, the three types: dipole-dipole, the hydrogen, and what? The London dispersion force. So what should you do, or what do you have for our learners?
Please do not forget to subscribe. Don't forget to share with your friends. And don't forget to like this video.
Good.
And if you have anything, maybe any question about it, just leave it in the comment section.
Good. I will do our best to read through and provide the necessary answers. Is that not so?
Very so.
Good. So for covalent bonds in organic compounds, let me just give you a trailer of it. We'll be defining what covalent bonding is, and then look at some interesting examples with interesting animations, right? How hydrogen fluoride is formed. Then we also contrast that against ionic bonding, how electrons are transferred from sodium to chlorine to form an ionic compound. Well, and we also get to know that covalent bond has to do with something like sharing. Good. So do not miss this lesson. So come back to have the full lesson on what? Covalent bonding. See you in our next lesson.